Let's talk about 10.2 today. Here we go. 10.2. Today we will talk about calculus with parametric curves. Last class we discussed what is a parametric curve, what is parametric equation. We solved few problems. Now today I will start with the calculus of parametric curve. To save some time, I already draw a curve here for you. Do you see this red curve like S shape? It is like S shape. If I ask you, if I have a point up, I'm sorry. If I have, for example, a point on this curve, let's name this point P. Is this point, or can I say, is this point P is defined on this curve as a function of y? Or if I name the curve in general C, is this curve is a function, this red curve? Definitely no, because to do a vertical line test, it is not even a function. Now, how to find, for example, the slope of tangent line in this point P, correct? To do that, in your book, they suddenly jumped to the chain rule, and even they didn't show you the proof. They gave you the formula, how to find the derivative of this or how to find the slope. But I will do a kind of short proof here for you. Just look from where I get the formula that you have in page number 689. To actually find the slope, which is the derivative at this point, let me cut this curve from the other 2 points. For example, this point and this point. If you just look for this small interval that I'm cutting this curve, this small interval can represent a function. Agree? Yes or no? From this point to this point. If I erase the rest of the curve, I'm dealing just with this point, this part of the graph. Is this a function? Is this part of the graph represents a function? Yes, no.
It would.
Yes.
Yeah. Okay. When you name a point, definitely this point has a coordinates of x, correct? And has a coordinate on y. Because we are dealing with parametric equations, we know that our x is f of t, right? And our y is g of t. Remember this idea from the first day that I start explaining parametric equations? If I name here this point f of a, what is the coordinates on the y? What will be this coordinates? If this is f of a, what is this on the y?
G of A.
G of a, excellent. G of a, because here, look at here, f of t, g of t, right? If I name, for example, here, this one, f of x, the coordinates on the y will be what? G
of x.
By doing this, actually, you see that you can represent this part of the function as a function of y in respect to x. Then I can, if I name that part of the function like capital F, I can represent this as a y y equal capital F of x. Correct? This part, this portion, let me change the color. This portion, which is a curve, it looks like a straight line, but see it as a curve. This part is a function of y in respect to x. Correct? At the same time, I have x equals f of t. Let's write those here because we need it. And also y equals g of t. If I replace here y with its value, I can write g of t equals f of, and replace x with its value, f of lowercase f of t. Any question what I did here? I do a bunch of substitutions here. I substitute the value of y here. I substitute the value of x here. Any question in this step? I want to prove the derivatives for you, correct? Now, let's take the derivative of both sides in respect to t. D over dt of g of t equals d over dt of f of t. The derivative of g of t in respect to t gives you g prime t, right? Equals. Now, look at your right side. Which kind of function you have in your right side? Which rule of derivatives I should use here? You are in calculus 2. It should be clear for you. What should I do here? Can you tell me what should I do here? On the right side, anyone? I have f, capital F of the lower f of t.
Chain rule.
Chain rule, yes. It's a composite function. The derivative of outside, it means f prime of f of t times the derivative of inside with lowercase f prime t. What is f of t? Let's replace the value of f of t here. What is your f of t? Your f of t is actually x, right? Then you can write g prime t equals f prime, the capital F prime of x times f lowercase f prime of t. Now, if I solve this equation for this, for capital F, then I can write f prime of x equals g prime of t over f prime of t. Or in the other notation that they used in your book, f prime of x means dy over what? dx equals g prime of t means what? G prime. It means dy over what? dt. Look at your function, g prime. If I ask you to find here, g prime, it's dy over dt, right? All over dx over dt. That is the formula that they show in your book, but they didn't prove it this way. I don't know, somehow by the reason they just used the chain rule to explain for you. This is the formula that you can find the slope of the tangent line to a parametric curve. You are using this method. Question? I will do examples. It will be clear for you in examples, correct? Definitely you will not ask question because you are not required to do the proof. Before going to an example, if, for example, I have this and now I'm looking for the second derivative, what is the second derivative formula? If I denote it this way, the second derivative dy, what happened to my pen? Dy over dx, the second derivative. To find the second derivative, replace your y with dy dx in this formula. Let's do that. I'll replace my y with dy dx. Then my second derivative means d over dx of dy dx. The second derivative, it means d over dx of this equation, equals fraction bar. If I replace y with dy dx, I'll end up this way, d over dt times dy dx. Agree? I replaced y with dy dx, all over dx dt. This will be the formula if you want to find the second derivative of your parametric function. Now, I will do one example of your book that has 4 parts in it, one by one, and you will see how I'm using these two formulas even to sketch a curve, find the tangent line to the curve, different tangent lines to the curve, also talk about the curve that it's concave up or concave down, what you learn in calculus 1, and after that even sketch the graph. Any question on these two formulas for me?
No.
Good. Let's do now an example. Example number 1 of your book. It's on page 690. A curve C is defined by the parametric equation x equals t squared and y equals t cubed minus 3t. It's a curve which is defined by these parametric equations. Part A. Show that C has 2 tangents at point 3, 0. They give you a point on the curve, which is 3, 0, and they're asking you to show that actually in this point, your curve has 2 tangent lines instead of 1. Correct? How to show that this curve has 2 tangent lines at that point? Your first thing to do is you have to find your dy dx, which is the slope of the tangent line. Dy over dx equals dy over dt over dx over dt. What is the derivative of this function? T cubed minus 3t. What is the derivative of this function? This derivative is 3t squared minus what? 3. This is actually your dy dt. Dy dt means take the derivative of this function. Dx dt means derivative of this function. Then your dx dt will be what? 2t. Now, I have to prove that this function has actually 2 tangent lines at the point 3, 0. Correct?
Mhm.
If you look at the top, which you have 3t squared minus t cubed, y equals t cubed, this function, t cubed minus 3t, correct? And if I plug in the value of t, 3 here, let's see what's happening if I plug in 3 here. And I'll set it equal 0, because 3, 0 means when one of them is 3, y is what? 0. Then y equals, here, if I factor this, I can write t times t squared minus 3. And if I plug the value of y0, it means t times t squared minus 3 equals 0. Let's solve it. From here, you can say t is equal 0, and also t squared minus 3 equals 0. It means t squared equals 3. It means t equals plus minus radical what? 3. This actually shows that you have two tangent lines, correct? And to find the value of the tangent lines, to find the equation of the tangent line, I know y minus y1 equals m parentheses x minus x1. Then y minus y1, how much is y1? It's given to you, 3. Equals m. What is your slope? What was your slope? How much is the slope? We just found the slope, two of them, positive radical 3 and negative radical 3. Let's use first the positive. Positive radical 3 times x minus x1 is 0. Then you can write from here y minus 3 equals x radical 3. Agree?
Mhm. Mhm.
Or even in this case, I am sorry, no one is telling me. I did a mistake, look. Y1 is 0, x1 is what? 3. Look at the point. Here, 3, 0, it means x is 3, y is 0, right? This is x, this is y. I plug it wrong way, and you're saying, yes, you are right. Y minus 0 equals x minus 3. It means y equals, let's erase this step totally, because everything is wrong in this step. Now I can say from here, y equals radical 3 times x minus 3, the equation of the tangent line. Also, I have negative radical 3, then my next equation will be y equals negative radical 3 times x minus 3, the second equation for the tangent line. Later in the graph, you will see that you have two tangent lines, that the equations are, one of them is this, one of them is this. Question for me?
Are you going to be, do you have a picture of this or graphing of this, of what it looks like?
Yeah, I will upload the picture here. Today, I just cut and paste the picture to show it the picture also. But let's wait, finish everything, then I'll show every single equation there, correct?
Yeah, I have a question.
Yes.
I have two actually, but solving for t for the y, how does that give you the slope?
Yeah. Because they give me this point, right, at 3 and what? 0. Correct? And if you solve this equation for t, any of them, even this one, if you solve for t, you will end up with the square root of what? 3. Because if you plug your y 0 and your t 3, actually x 3 and your y 0, In this case, you will end up with this radical 3, which is the slope, right?
So solving for t gives you the slope.
Yeah, I solved for t. You see, I just pick one of them. I don't need to this one or the other one. I take this equation and I plug in the value which is given to me. X is 3, Y is what? 0.
Okay. And the second one was, why did we solve for dy over dx? Like, how did we didn't use it at all?
Which one? I will use it right now. The X, this one?
Yeah.
X1?
No, the 3/2 squared minus 3 over 2t.
Oh, I need it. Right now, I need it for the second part, correct? Let's wait.
Okay.
I need it. Correct?
Yeah.
Even you see, if you solve this one for t, you will end up with radical 3, correct? If I plug the value of t even here in this derivative, I'll get the slope as a plus minus radical 3. Correct? Which way I go, I'll end up with the same answer. Part B, they are asking you in part B, find the point on C where the tangent is horizontal. Find a point on the curve C, which point, we have to find this point, when the tangent is horizontal. A question for you. When the tangent is horizontal, what do you think? How much is the slope?
It's like perpendicular to it.
No, when you have a horizontal line, what is the slope of horizontal line? How much?
0.
0.
0, really good. Then look at this. You have dy over dx equals dy over dt over dx over dt, right? When you can get the slope 0, what should I do here to get this one equal to 0?
Inversely.
No, I thought like you were gonna set the
If
left
your
hand side to 0.
numerator becomes 0, dy dx becomes 0, right? Look, dy dx becomes 0 if dy dt is equal to what? To 0. It means let's put this derivative equal to 0. I have y equals t cubed minus 3t, then dy dt, the derivative of this function, equals 3t squared minus 3, correct? Let's make this one equal to 0. You see, dy dt equals 0. It means 3t squared minus 3 equals 0. It means here you can say, if you divide everything by 3, you can say 3t squared minus 1 equals 0. It means t squared equal 1. It means t equals plus minus 1, right? Question on this step? This function, because they said that find a point that the tangent line to the function is horizontal like this. If the tangent line is horizontal, the slope should be 0. How the slope becomes 0? It means dy dx should be 0. When dy dx can be 0? If the numerator is 0. What is numerator? Numerator is dy dt. Then dy dt should be 0. And I found dy dt, correct? Now, if I plug back the value of t in this equation, which I have y equals t cubed minus 3t. Remember calculus 1? If I plug in this value here, I can find the points that the tangent is horizontal there. Y equals, let's start with positive 1. 1 cubed minus 3 times 1, then y equals 1 minus 3, which is negative 2. Next time, y equals negative 1 cubed minus 3 times negative 1. It means from here you can say y equals negative 1 plus 3, which gives you positive 2. Then I got 2 points. When t is 1, you end up with negative 2. When t is negative 1, you end up with positive 2. These are actually the points that the tangent on these points will be a horizontal line. Question? Good. Next step. When the tangent line is vertical, at what point I have a vertical tangent line? Again, look at your equation. dy over dx equals dy over dt over dx over dt. When I get a vertical line here,
When it's undefined.
when it's undefined, excellent. It means dx over dt. When dx over dt becomes equal what? 0.
Zero.
When your denominator is 0, remember you have a vertical asymptote at that point? Then let's do it. I have x equals t squared, right? Then dx dt equals 2t. And let's put this one equal to 0. From here, I can say 2t equals 0. It means t equals 0. And if I plug the value of t back here, I'll get x equals 0 squared. It means I get a point 0, 0. It means at 0, 0, my curve can have a vertical tangent line. Any question?
Is that the same? Is a vertical tangent line the same as a vertical asymptote?
Yeah, no, vertical tangent line. Yeah, it is like the same idea of like vertical asymptote, but it is a tangent line. It's not a vertical asymptote. You can have a vertical tangent line. You can draw a vertical tangent line there, correct?
Oh, okay. So it isn't the same. I get it. Okay.
But the idea is the same, right? To put denominator equals 0. It's the same idea. Part C. And part C, determine where the curve is concave up and where the curve is concave down. A good student from Calc 1, when you find the interval, when the curve is concave up or concave down, what should you do?
You should get the second derivative, and if it's positive, then it's concave up. If it's negative, it's concave down.
Good job. 3 points, extra point for you. Thank you.
Is this where you would use to draw a line and we would use like draw a number line? Did we do that
Sign
before?
chart, yes, but here we don't need, because right now we have enough knowledge of that. Even you don't need a kind of number line, but yes, if you want, you can do that. But first I have to find the second derivative, right?
I want extra points. That's what I wanted.
Okay. And now you're looking for the second derivative of our function. The formula that I just proved for you, the second derivative is equal d over dt of dy dx all over dx dt. Now, what was the derivative of dy dx? We take the derivative of dy dx. My dy dx, I already found it. Let's copy it here. My dy dx is equal 3t squared minus 3 over 2t, right? This is your dy dx. We did it in a step 1. Agree? Let's find the derivative of this. Then d dt of dy dx equals d dt of this function. D dt of 3t squared minus 3 over 2t. Which rule is this? Quotient rule? Let's apply the quotient rule. Then this one equals g, which is 2t, times the derivative of the top, which gives you 6t, minus f, which is 3t squared minus 3, times the derivative of the bottom, which is 2, over denominator squared, 4t squared. Any question? I applied the quotient rule. G f prime minus f g prime over g squared. Question? Now, let's distribute, simplify. 2t times 6t gives you 12t squared. Negative 3, look, 2 times 3t squared times negative gives you negative 6t squared plus 6 over 4t squared. Let's simplify a little bit more. D over dt of dy dx equals actually 6t squared plus 6 over 4t squared. Can I factor out 6 in the top? Yes. Then t squared minus plus 1 inside over 4t squared. Reduced by 2, it gives you 3 times t squared plus 1 over 2t squared. But I'm not done yet. Look at my formula. Here, I have to plug it in this one. I just calculate the top portion. I just calculate this one. Now I have to put it over the x dt, right? Then I can say the second derivative equals this function that I just calculated for you, 3 times t squared plus 1 over 2t squared, all over dx dt. What is dx dt? How much is dx dt? Your dx dt is 2t because you have x equals t squared, right? Then dx dt will be 2t. Let's simplify this. It's equal 3 times t squared plus 1 over 2t squared times, flip this one, 1 over 2t, which you end up with 3 times t squared plus 1 over 2t cubed, my second derivative. Now, you talk about number line, right? Look here. If t is greater than 0, if I plug in here a positive number, what will be the value of the second derivative, positive or negative?
Hey, I have a question. How
Yes.
did 2t squared times 2t become 2t cubed?
40. Thank you. I'll deduct points. 4t cubed. 2 times 2, 4, t squared times t cubed. Thank you. Now, if t is a positive number, for example, let's plug in 1 here, a number greater than 0. Your second derivative becomes positive, right? This thing becomes positive also. When your second derivative is positive, then you have, in that interval, your function or your curve is concave up, right? For the values t greater than 0, you have concave up. For the values t less than 0, a negative number, plug in here a negative number, you will see you will end with a negative. It means your curve on that interval will be concave what? Downward. Question? Now, let me show you the graph. Can I share another screen with you? Are you done with taking notes of these? Can I go to next screen?
Mm-hmm.
Yes.
Here. Because in last part, they're asking you actually to graph, right? Look at here now your graph. This is the graph of that function. When t was equal -1, you see you can have a horizontal tangent line. At t equals -1 and t equals +1, you can have two horizontal tangent lines. This line and this line that they're passing from 3, 0, these are those two tangent lines that the equation was the equation was square root of 3 times x minus 3 here in the top. Y equals the square root of 3 times x minus 3 and y equals the square root of 3 times x minus 3, this one. You have two tangent lines that they are crossing from 3, 0. They are passing from 3, 0. And all those points here at 0, 0, I told you that you have a vertical tangent line. Look at the y-axis. It acts as a vertical tangent line for you. And if you connect all these points in your notebook, you will end up with this graph. Question for me.
What is this called again?
This is calculus with parametric curves.
And the point of it is to find these tangent lines, the functions, the y equals the square root of 3.
Tangent line means find the derivative of the function, right? Actually, you found the derivative of the function, the first one, the second derivative, and also if you want to graph, you can graph right now the tangent, even the tangent line, right?
Right. I was just trying to figure out the point of this.
Yeah, next I will go over the finding the area under this curve. It means we will deal with integral, right? To find the area under the curve, but parametric curve, not a normal curve, correct? But right now I have really less time for that. I'm not going to overdose, correct? And today is a special day for me. Today is the day that your professor was born, and like 80 years ago.
Yay! Happy
wait,
birthday!
Oh, wait, what? Wow.
Thank you. My family is waiting for me. I'll go and join my family because we have like only 10 minutes or no, actually 20 minutes.
Yeah,
Thank you guys. Thank you.
yeah, happy birthday.
Next day, I will cover for you the area under this curve. Then we are done with parametric curve. I will start also next day with the polar system. What is polar system? First, I'll explain what is polar system. Then next day, we will jump to the calculus of the polar system, correct? And I will stop definitely on that point, and I'll jump to next chapter to give you an idea of the sequences and series also, correct? Hopefully not today, by tomorrow evening or Saturday evening, you will receive the copy of your test 3 study guide, correct? I will send it out maybe tomorrow or maybe day after tomorrow.
When's our test?
After I send you the study guide, I also put a date for the test, maybe by end of next week.
Okay.
But again, read your syllabus. Those of you that you were my student last semester, you know my method that if you have a high grade in test 1 and test 2, and you are satisfied with your grade, even you are not required to take test 3, because anyway, I'm dropping one of those tests with lower score, right? It's up to you. But I'm encouraging you to take test 3, even if your number goes down, who cares? I'll drop that one to practice for your final, because everything that right now I'm teaching you comes to you in final, correct?
Well, go enjoy your family. Happy birthday. Thank you so much.
Thank you, guys. Thank you. Have a great day and be safe. See you Monday.
Professor, I have a question actually about the graph. I've got two different one different horizontal asymptote because I've got a 1 and a -2, which was there, and a -1 and a 2, which wasn't there. It was 1 and 2.
Where did right?
Yeah, where did the -1 come from? Because our t was +1,
one of them
-1.
was -1 and 2, right?
Yes.
And the other one was 1 and -2.
Oh, so why does it say the top one is 1 and 2? If our was -1.
This was
2.
the point that we calculate, remember?
Yeah.
At what point you have a horizontal tangent line? At 1 and 2 and
1 and -2. All right. I don't know why.
No. Here there is a mistake.
Okay.
This one is, which one was 1 and -2? One of them was 1 and -2?
Yes, and the other one was -1 and 2. That's where the -1 is kind of throwing me off.
No, we don't have -1. Both of them is 1 and 2 and 1 and -2.
Okay, it must have just been something I wrote wrong.
Maybe I did a mistake with the sign, right? It's 1 and 2 and
Well,
-1
and -2. All right.
Yeah, 2 values.
Thank you.
Any other question for me? Can I end the meeting now?